Hi geometry students! I decided to make this short video for you to talk about volume. Okay, so it's kind of zoomed in tight because we're going to do a little bit of work here and look at some different things that are going to be volume calculations that you're going to be working on this week. All right, here we go. So I purchased these two measuring cups that you see right here, okay? And the reason for this purchase was to talk to you guys about things that you can do when you're comparing changing the proportions of and the dimensions of a solid object and how that is actually related to volume, okay? So I went ahead and I just traced each of these circles that you see here. And what the relationship is that the diameter of this circle, and hopefully you're going to be able to actually see this circle. I'm not quite sure how well this will show up, but we'll give it a shot. That the diameter of the circle is 4.3 centimeters. Okay, so 4.3 centimeters right here. And the diameter of this circle is 8.6 centimeters. So it's twice as big, one diameter and the next. And when you're calculating volumes of solids, either, and this is like a cylinder, right? You see how that can be a cylinder? It has a circular base and then a height. And when you're calculating either a cylinder or a prism, and this would be an example like of a rectangular prism, so it has a rectangle that is the base, and then it has a certain height, so that would be a rectangular prism. This would be a rectangular prism as well. You could use any side as its base. You could call this its base, and find the area of that base, then multiply it times the height. Okay. These are examples of cylinders, so other examples of cylinders happening right here with just some cans. So you'll have an assignment that kind of will allow you to play with some of those solids this week. All right. So the big thing here that I really wanted you to see is that when we increase the dimension of a linear measurement, so if you take a linear measurement, which is a dimension like the height or the diameter of a given figure, and you have a ratio here, and what we've done is we've taken this 4.3 and we've multiplied it by 2, okay? So we've multiplied that, the dimension by 2. What happens to the area, okay, if we were to find the area of this circle, which remember to find area, it's pi times the radius squared. So to find the area of this circle, we would take pi times not 4.3, but the radius, which would be like 2.15, half of that, squared, and find the area. Well, what ends up happening with the area, as we change the linear dimension by 2, is the area dimension actually gets multiplied by 2 squared. So the area gets 4 times bigger, okay? So this is going to be a proportion that we would have studied had we had a little more time to work on volume. But I still wanted you to see it and see how this kind of expands our knowledge of how volume, linear relationships, and area are related. So as you make a dimension 2 times bigger, right, the area is going to be 4 times bigger, and then the volume is going to be 8 times bigger. So it's actually times 2 cubed. Right, so it becomes 8 times bigger. So this was just sort of a real life example of how that happens, and I'm here next to my sink for a reason, right? Because we're gonna kind of pan over and I want to show you this relationship. So this small cylinder, see how it has a diameter that is exactly half of the diameter of the larger cylinder, okay? And its height actually is exactly half of the height of the bigger cylinder as well. So both of the dimensions between these two cylinders, both the diameter and the height, have been doubled. So how does that change the volume then, is the question, right? So let's come on over here. The volume should be, according to our calculations, it should be 8 times bigger, right? It should be 8 times bigger. So I'm going to swing us over this way just a little bit, just like that, okay? And let's see if it in fact is 8 times bigger. So if that's true, then 8 of these small cylinders should fit in this larger cylinder, okay? So there's 1, 2, 3, 4, 5, 6, 7, and 8. And there you have it. So you might have guessed that this is actually a 1/8 cup measuring cup, and this is a 1 cup measuring cup. But see how those dimensions make the difference, right? You have double the size on the diameter, so the volume is 8 times bigger. All right? So I wanted to just show that to you. It's kind of a cool demonstration of how those things change. Okay, I'll get rid of that. And this week we are going to be working on calculating volumes of solids. So I will give you a little bit more of a formal lecture on how to calculate things like volumes of cones, volumes of spheres. Here would be an example. You could do something like any kind of a ball in the house as an example for your finding the volumes of solids. I already gave you some good examples of some things in boxes. Toblerone candy bars. I'm gonna go and get myself one of those because those have really cool boxes and they're kind of fun to find the volume and surface area of those. So this week we're focusing on volume, and I hope this little demo helped you learn something. All right, guys, I'll talk to you soon.